Hey everybody, it's Mr. Salmingo again. Hope you guys are still having a good vacation. I want to thank all of you that have been following along at the forums. I know some people don't like it and some people hate it, but I really like being able to discuss with some of you and answering your questions, even though we're on Easter vacation. So I saw there's a whole bunch of questions. I think if someone asks it, I really doubt they're the only person that has that question, so I thought I'd go over the questions one by one, maybe in a very short video so I can explain it to everybody, instead of just that one person. So I'm going to start with Aldrin. Aldrin says, practice on the math part. Yeah, I get that. It says, can you explain ground fires? That'll make sense how they burn underground for days. Ground fires are, essentially, they are burning, here it says layer of duff, roots, and buried or partially buried dead and decaying logs. So we're talking about stuff that's sort of underneath, okay? So there's stuff that's buried, and they burn, here it says, and they burn very slowly with little, if any, flame. So ground fires, they could burn for days because they burn very slowly, and they're actually underneath. Remember we called like leaf litter? So, you know, branches and leaves and twigs, all that stuff. Like that stuff still stays on top, but the roots and the logs that are underneath them, that's the stuff that they're burning with ground fires. He also says, can you explain the difference between convection and conduction? It's a great question. Convection, if I could make this picture bigger. Convection is just something I've been talking about in the forums already, but it's essentially a circle in which warm air, warm water rises because it's getting heated, and as it gets farther and farther away, it cools down. And when it cools down, it gets heavier, so it sinks. And when it sinks, it gets closer to the heat, and it rises again, it gets warm, and then as it gets farther and farther, it gets cold, and it sinks, and that cycle happens over and over again. That's called convection. It's this motion of molecules. When things are hot, it rises, and then when it gets cold, it sinks. Conduction is actually very simple. You guys probably studied conduction in elementary school, but it's just saying that energy is transferred across anything. The best thing you can think of is metal. So in this picture, if I heat up a pot and I touch the pan, it's really hot at the handles. Even though I'm not heating up the handle, I'm heating up the bottom of the pan, it's conducting through the pot all the way to the end. So it's basically a one-way transfer of energy or heat. In this case, it's a pot. Lauren asks, the laws of thermodynamics, how do you tell the difference? And then also nuclear energy. Nuclear energy, a lot of people actually asked about that also. Laws of thermodynamics, there's only two, and it's not meant to be so difficult, and I know it's hard to memorize everything. First law of thermodynamics, energy can be changed from one form to another, and it cannot be created or destroyed. So we're saying that energy, it can turn into heat. I mean, the basis of this law is saying that if we get all this energy from the sun, basically, shouldn't we have like unlimited energy? And, you know, stuff like that. We're trying to say that energy, it can be changed from one form to another, but we can't create new energy sources. So the sun is their ultimate source of energy, but after that, the sun, you know, if the sun were to burn out or anything, it's the only source that we have that creates other forms of energy. So we can't create it or destroy it, and eventually it all turns into heat, which is an unusable form of energy. The second law says that if you exchange energy, like I convert energy, like from a battery to your cell phone, or from gas to a car, you lose quality of the energy. Basically, you don't get as much quality anymore if you keep exchanging it. Or another way that my teacher used to think about it is like if you keep selling something, or you keep, I don't know, passing something down, its value decreases just naturally. Okay, so if I have I don't have a good example, but anyway, long story short, if you have something that's high quality and I pass it down or use it, it always decreases in quality. And we can talk about that later if you guys understand. Kiki asks, what's ecosystem capital? It's actually not so difficult or not as complicated as many of you may think. When we talk about, oh wait, I forgot to answer Lauren's question about nuclear power. Okay, nuclear power, something we've gone over many times, but some are still confused. Here's the basics of it. Here is where the interaction happens. We're talking about nuclear fission. Fission is when you get two nuclei and you smash them together, and that, Fission. Fission, you have one gigantic nuclei, and you hit it with protons, and it breaks up into smaller pieces, and that generates a whole bunch of energy. So the one that they use primarily is uranium. So those collisions, okay, here's the control rods or these fuel rods, and those collisions create a lot of heat. And that heat warms up water here, and that water being heated creates steam. And that steam, as we talked about, spins a turbine which can power a generator. Once that steam is used to power the turbine, I mean, it's not very useful because we just used all this nuclear stuff to warm it. So what they do is they condense it or they cool the steam back down into water, and that's sort of the stuff that you put in those radioactive cans. And then the stuff that is still usable, they put it back in the pump and they try to recycle it over and over again. And that's how a nuclear power plant works. So hopefully that answers your question. As it says down here, don't confuse fission with fusion. All nuclear power plants, almost all of them in the world, not just the US, use nuclear fission, which means large atoms are split into two smaller atoms. Okay. Key's question is, what is ecosystem capital? Ecosystem is basically all the resources that you have in an ecosystem. So fossil fuels are capital. The word capital in itself means what's all the stuff that you have. Key had also another question about what's the difference between contour plowing, terracing, and no-tilling. Okay. Oh, here's an ecosystem. Basically all the resources needed for humans to survive or organisms to survive. That's ecosystem capital. All right. Terracing. People in the Philippines are familiar with terracing because they usually use it for rice or making rice. So you see these rice terraces. Essentially, they take hills and they make steps. So here's one in Indonesia, Mississippi. This is China, and this is Vietnam. So terrace literally means almost like steps. So they use it on sloped land to make it, think of it as giant steps. Okay. Contour is that they take the existing slopes and sort of work and weave their way around it. So here are some pictures of, what they say, contour plowing. So if the contour of the land looks like this, we're going to farm to the contour. And that's good because I don't use or waste a lot of water. I also don't have to ruin the land. This is what they call contour plowing or contour farming. And no-tilling is just, if you were to grow something, you how can I say this? You tend to grab a tool like a hoe and then you mess up the land so you can grow crops in it. No-till farming, another way to think about it, is direct planting. So you just see dirt and you plant it. That's what you call by no-till, which means you don't have to use as much water or nutrients and you don't erode the soil. That's called no-till. All three of these, contour, terrace, and no-till farming, you should know these as what are good environmental ways to farm. All right. He says radiant energy is just sunlight, right? Yes, radiant energy, radiant rays, is just sunlight. Exploratory wells, scrubbers, I'll talk about exploratory wells when I see you guys. Scrubbers we talked about, remember they're the stuff they put in factory smokestacks to make sure that the air that comes out of factories is clean. Geothermal energy, good question. A lot of people had the question about geothermal energy. So, oh yeah, and Key also had a question, what's a green belt? We talked about this a while back, but a green belt is if you think of a city, and on the outside of a city they have an open or forested area. They call that, it's just a nickname, a green belt of the border of a city that's just all green. So let me close some of these tabs here. Geothermal energy. So geothermal energy, in short, is basically taking steam that comes out of the ground and using that steam that already is naturally coming out of the ground and use that to spin a turbine and create energy, which is good. Okay? Unfortunately, there isn't that many places where you can have geothermal power, which is why we don't use it. As a matter of fact, it supplies less than 1% of the world's energy. Here's a picture of a geothermal power plant. So the good thing about it is that it's reliable. I mean, the steam's coming out of the ground. Think of geysers. It's renewable. There's no emissions. There's no global warming. We don't really destroy the land. We conserve water. So we like geothermal power plants. The only problem is, and you should know some of these, it's pretty expensive. There aren't that many places in the world where there's just steam that comes out of the ground. Even though you don't, you might create sinkholes. And then if you manage it poorly, you could accidentally take all the steam and then it never comes back again. So here's a cool animation of how geothermal energy power plant works. So for example, here's what they call a cap rock, and there's a space that they have identified that where steam can come out. So what they do is they create a well. So this is the well that they want. This is where the steam comes out. But once they get the steam, they need a place to put it back. So they create a second well called the injection well, so it flows through properly. So I extract the steam to create energy and spin a turbine, but once I'm done, I have an injection well to put it back into the ground and let it recycle itself. On the inside, we talked about this already, but it then spins a turbine. So, ta-da, in the plant we have a turbine. That turbine, again, you don't need to know the mechanics of it, but it generates or creates drives an electric generator, which then you could, if you put in an electric generator, you could put it through power lines, and now you can power cities, towns, whatever. That's geothermal. Oh yeah. And then not only did she ask about green belts, but she also asked about gangue and tailing. So when you mine, say for example you're mining coal, you don't get perfect charcoal bricks in the mines. Like they're not that nice and pretty. There's all this stuff around it. That's what you call gangue. So gangue, they call it the uneconomic fraction of ore. So if I mine something great like coal, I don't just get coal. There's all this other stuff that we don't want with it. That's called gangue. All this other extra stuff that we don't want. The extra stuff that we don't want, if it's like trash almost, they call those tailings. Or they call them mine dumps, slimes, tails, refuse. So it's almost like trash. Or think about it as the wrapper of a chocolate bar. Or think of it as the bag of hot Cheetos. You want the hot Cheetos, you don't want the bag. So the bag essentially is considered gangue or tailings. Okay? If the extra stuff is something that we may want, they just call it gangue. If it's something that we don't want and it's something you throw away, they call that tailings. So hopefully that explains it. And then the last question that people had, thermal inversions. First, thanks to Aldrin for explaining what noise pollution is. But thermal inversions is also something that people are confused about. Thermal inversions, let's think about it this way. So here's your house, and we're in California. And remember, naturally, what should happen is if you are near the ground, it's sort of warm. And as you get higher and higher above the ground, it should be colder. Those of you that have gone snowboarding and gone up the mountains, you should know that as you go up or higher in altitude, it should get colder, right? So, but the problem is that in some places like California, not only does it get cold, but at some point there's relatively warm air. All of a sudden it gets warm. And the question is, where does that come from and why is it there? Well, if you look at this paragraph, and we're the worst people about it, but we're talking about in California, upper air inversions develop because much of California is on the eastern edge of a subtropical high pressure cell in the Pacific Ocean. Or those of you that watch the news, we've got this high pressure cell and we're on the eastern edge. Okay? The high pressure cell develops in response to global patterns of atmospheric pressure and circulation rather than local conditions. The presence of high pressure means that air in the region is subsiding from high altitudes in the atmosphere. Subsiding air is compressed by the increasing pressure of the surrounding air as it descends, so the air warms up as it subsides. So not only is there cool air at ground level, but there is also general subsidence of warm air aloft. So maybe some of you may not understand what the heck I'm talking about. So because there's this high pressure system, there's some air up here that sinks. Okay, so there's this high pressure system all the way up here, and it starts to sink. As it sinks, it gets warmer. And as it gets warmer, it sort of settles here, and it creates an inversion layer. If there are mountains inland, the mountains can also help trap air. So California, or Los Angeles rather, we have mountains on the side. So not only are we the edge of a high pressure cell where warm air is sinking, we also have these mountains, and that creates this inversion layer, where all of a sudden I have a sandwich of warm air here at the top, warm air in the bottom, and cool air in the middle, so smog in the middle can't get out. That's what we call a thermal inversion. Okay. So that's all I wanted to explain to you guys. I don't want to make this video too long. We have some questions from a lot of other people as well that we can tackle, but I wanted to tackle those main ones because I know all of you might have those questions as well. You know, Isabel is asking about greenhouse gases. Alex is asking about, she asked about thermal inversions also, but surface impoundment, NOx and SOx. We'll go over that stuff when we get back, but I just want to make sure you guys understand those main points. So hope you enjoyed the video. Hope somebody's out there is watching it, and I'll see you guys when you get back. Take care.